Great. So thanks a lot for the work that you posted. Double Sarah, Mazen, Luis, and Dimitri as well. How was it? Are there any questions before we start this lecture? Somehow all of you, like almost most of you, managed to add some cool gifts, which I always appreciate. This one not playing for some reason. Play, play. Yeah. Ah, cool. Is Dimitri here? Can you unmute yourself for a second? Which script did you use for this one? Is it something that you created, or is that following the other example that we had in our Grasshopper 5, the mesh networks? Okay. Okay. I think okay, you can unmute. No worries. Thanks for your work. Looks great. Sarah as well. You were too excited to make two, so thanks for that. I was actually expecting you to at least like change the like the kind of the input surface logic, but it looks great. Um,
Yeah, I tried that because I noticed that when I changed the form, well, first of all, hi guys.
hi.
It's seems that on my the first surface that I tried, it doesn't give me much variation in Houdini. That's why then I tried to go back to the form we did together to make sure I got, the base
Okay.
script first.
Okay. Yeah, I think you'll have like better knowledge of how to tweak Houdini's parameters today because we have like three different exercises, and from there, I would expect you to get more acquainted with um these different setups. Ah, this one is great. S- So you
And
kind of
then,
yeah,
yeah, just exaggerated the form a little bit.
it's
Try
kind of
to
created like a nice canopy in a way now, which is cool.
And then I was wondering, how do you retain the color of the surfaces? Because I followed the tutorial from yesterday and then I got the colorful points. But then I saw that in your example, the third image is actually the surfaces or the
So
faces of the meshes
I'm
are colored.
at the end of the last lecture, like right at the last minute, I was like, oh, we ran out of time. So I didn't show how you can change the attributes for being for points for colors and average them for each panel because there's a different number of panels to points. So you need a different list of numbers that is by the panel or by in Houdini's case, primitives. And to bring that list in the file that I put on, I just added in that because it's just one component, but I'm going to show that like in a few minutes.
Awesome, thank you.
Okay, great. Do you have any more questions, Sarah? Okay. Mazen, thanks a lot for your work. Do you have any questions or any struggles that you had while working on this?
No, but I feel this amazing experience for because I didn't use Kangaroo a lot, but now I can use a Kangaroo and make something weird project, but it's very cool, yeah.
Yeah, a weird geometry is a nice way to
Yeah.
put what we're doing in. So thanks for that. Anyway, I thought you made like a cool effect on your image because it's pixelated, and
No,
it
it's
seems like
light.
it's intentional, but when you zoom in, you just realize it's just pixelated. Or did you
Yeah,
do something? Not
I
sure.
I I I I I I uh,
Is the path?
I converted it online video to GIF, so it
Uh,
make
okay.
it pixelated.
It seems like there's like a pattern overlay. Anyways, cool
Yeah,
effect. It happens, yeah. Uh, Luis, thanks for your work. Have you had any questions while working on this?
Not for the moment. I just had issues with saving from Grasshopper to Houdini. the files, but then I just copy pasted the one that we were working on yesterday, and it worked. So it was like a
So I
bug,
mean, it
I
was working
guess.
with one geometry, but not working with the other?
In one file, the connection between Houdini and Grasshopper was working, but in the new file wasn't working. But then I just copy pasted all the components and
Okay, but it
started to
worked with
work.
the same geometry that you wanted to push is now working, right? I'm asking this because sometimes you might have interoperability issues because of your mesh, not because of your setup is not working, right? But I think you're saying that the geometry that you were working on was actually sent to Houdini, right?
Yeah,
But with a
now that I
different, but
remember,
Is
yeah,
this,
I had to adjust the threshold, I think it's called, the threshold from the Kangaroo physics solver. I had to like put a number so that the solver stopped calculating. And
converged.
when
Okay,
it exactly, then when it gave me converse, then I could save it the files.
okay. On that note, I wasn't planning actually to run Rhino and Grasshopper, but maybe because yeah, changing the tolerance will affect somehow how the solver is like calculating your geometry. So I might even see that with lower threshold, you might even accept like more transformations or less transformations sometimes. So that's how the convergence. But anyways, you are free to just toggle the Boolean component that you're adding and stop it at any point that you want, right? So even so if you don't want to wait it actually until it reaches this equilibrium state, you can just turn it off and take whatever it's whatever the output and pass it to Houdini, okay? In some case. Because sometimes actually your interesting output is one of these steps that are predefined. So it's okay to stop at any point. Yeah, more to come, I believe. Participation is a key, as we said yesterday. So let's move to one slide before we move on the hands-on part. Today's lecture should be exciting, I believe. So officially welcome to session 2 of the Fictional Structures workshop, part of the Digital Futures 2024. And today we have 5 parts. So the first one going to be the Houdini recap by James. So he will be going through yesterday's last part session, showing you the other parts that he didn't manage to finish yesterday. And then we will have a lecture about noise. And noise kind of will be the key driving force for all of the different simulations that we are going to run today in Houdini. So it's really important to understand the concepts first before we get to the application. And then we have an exercise about attributes. So this is going to be a good opportunity for you to understand the different geometry types in Houdini and how you can tweak attributes as well, which is something I believe James have touched on already, or maybe to some extent with yesterday's and today's recap as well. And then we have another application on noise, and then we have a break for 10 minutes, and then we go back with growth, which is kind of the main exercise today. And with that, we'll conclude session 2 and move to session 3. We'll have the geometry back to Grasshopper and apply distillation, but also learn how to render the simulations that we're doing in Houdini. And with that, I will hand it over to James. Hi, Esther. Good to see you. You weren't here yesterday, so have you managed to watch the recording? Esther?
Can you hear me?
Yeah, I can now.
I was late 20 minutes, but I was hearing. I watched
okay, perfect.
Yeah, I watched the recording, but I didn't finish, to be honest.
Okay, it's fine. It's fine.
I'm sorry.
the recording?
No, it's totally fine. I was just making sure that you got access to the recording and you can catch up with today's
Yeah,
topic.
I saw it on YouTube.
Yeah.
Fantastic. I was just going to show this one diagram in terms of Kangaroo and how you can use target points things. So these are points that were raised on the z-axis with a sine, a graph remapper and a sort of sine wave. So the z values are all sort of controlled as a sort of sine wave of values. And as long as it's sort of matched as a full circle, then you get this sort of interesting thing that then was used to create the roof structure that sort of opens up, kind of like sort of just opens up to these little windows, the difference between the green points and the red points. So that's sort of a use of anchor points. That's kind of interesting, I thought. What's that? So this is kind of where we left off. I just mentioned this last component here. One way to get it off, although I always find this doesn't work that well for me, but one way to get these out of their thing is you just shake them really hard, and there you go, right? So it kind of works sometimes. Maybe you just have to shake really hard. But so I left without this.
James, why do you have to shake the node?
To get it out.
Ah, okay.
So it's linked there, and you kind of just.
Okay, cool.
Okay, let me zoom out. I mean, I could just delete it. There we go. Yeah. I'm not sure if there's I'm not doing it right or something, but I just excessive shaking is how you can get it out. You could, of course, just delete it, or another way, by the way, to do it. If you hold down Y here, you get the scissors, and you can just cut, and you can also sort of like make your random cut pattern around your geometry and just cut whatever wires you want, and get that out. So anyway, if we go here, let's see, just G, me that there. Okay, so with this, go to the geometry spreadsheet, and this little icon up here is the point attributes. So these are the kind of columns of data that are attributed to points. And we can see that there are p-value, px, y, z, that's our point position in space, and cd, which is our colors, but that is for the points only. And if we go to this one here, which is primitives, this is vertices, and this is details. So this is primitives, which is the faces. We can see we have nothing there, right? So I'm going to create this from scratch, actually, rather than do it. So to do attribute promote is the command that we can do there. And rather than type attribute promote the whole way, you can just do a promote, and it should find it. So a promote, and there we go, right? And we put that in there. And so you get this warning message because it's not set up right. And from geometry spreadsheet, go back to where the parameters are, this first tab, and we can see the original name, the original class, the new class, whatever. So we're taking a point attribute, creating a new class as a primitive attribute. The original name, the attribute that we're changing is the color attributes. So we put the CD for color, and average is fine. And that just means that, you know, every face has 4 points at the edge of it. In this case, those 4 points each have 4 different colors. Each face is going to take the average color of the 4 points that are around it. Quite simple. This delete original tab is kind of interesting. So if I leave this checked, which is its default position, that means I will lose the color attributes for the points. So I'll sort of be losing information there. So that example I did yesterday, so I can uncheck that so that I keep the columns for, so now I see that these are newly created. That's color attributes for the primitives. And then here is color attributes for the points are still there. If I left this checkbox on and I went to geometry spreadsheet, they're now deleted and replaced here at the color CD color attributes that I've done there. So I guess this is sort of how efficient I want my file to be sent. How efficient I want my file to be sent. Do I want to kind of be efficient with data, or do I want to sort of all, I'm just going to delete original. This is not a heavy file. So then if I click save with the blue line there, or the blue tab, I can delete this because this is now repeated. And I go to back to Grasshopper, and I've sort of slightly edited this, but I still have my file being read, and I have points and primitives, and get the Houdini attribute with, let me just open the Houdini one. Right, so get my attribute, and if this was points, it would get the point attributes. If it was primitives, it gets the primitive attributes. with the attribute type. This is all the exact same as yesterday. All that's different from yesterday is I changed from point to primitive. And then in the same way as yesterday, list item to get the list of 3 numbers, put them in the sort of format of number, comma, number, comma, number. And then you can do the meshes that come in, color each mesh. In this case, the data structure here, these are on a branch. These are grafted from being flattened to be on the branch. So now these data structures match. And I just flattened all the meshes so that we can join them into one mesh. And does that make sense to everyone?
If I may add one point here, one nice feature about using meshes as well inside Grasshopper is that you can attach attributes to faces or vertices inside your script, which if they are not colors, you might need to actually attach them. So later on, you can even restore them back in a different form, like in a different format. So if you get like the mesh attributes component, James, you can look at this later on your own, like everyone, where you can explore how you can add attributes. So the command or the node inside Grasshopper called attach mesh attributes, and that should do the trick. Yeah, maybe. Yeah.
I'll look later. Maybe that's a better way, but anyway. So
sorry, I wasn't meaning it's an alternative way. I was saying if you don't want to use your attributes as colors, then maybe you can attach those attributes to your mesh, right? It's like completely different from adding colors.
yeah, okay. So coming back to Houdini, what else can we do sort of here? So one thing, if let's go from let's sort of use Y and just disconnect it here. And let's add a bunch of things going on here. So this is just my regular mesh, and I'm going to do a scatter. Yeah. Scatter, which is going to scatter points. This is kind of got the number here, and I can just basically scatter any number of points on the mesh like that. So I'll just leave it as something small while we kind of get this working. And then I can use copy to points, which allows sort of 2 inputs. The first input is going to be what I want to copy to all of those points. And the second one is the points that would be copied to. So if I do a tube, for example, and I want to copy the tube to all the points and see what that looks like, I see that it's basically copied that all. And it's sort of taking the color that's already associated with each point and sort of using that as the color for the tube. So when I go to tube, I also have the option for end caps that just sort of allows there. And I can kind of mess with the parameters here and sort of scale down and do different things like that. One thing as well is to capture the normals so that the normals will start shaping the tubes. So I can get the normal. I think that would want to go in here. And if I just slot it in the middle, it will sort of expand my script and put it in there. So now the normals are part of the geometry spreadsheet, and those normals are also going to be applied to controlling the direction of these tubes. And when I scatter is now the point of which I can increase or decrease the amount of scattered points, which will increase or decrease the amount of tubes that appear here. So with the tube, I could transform that tube's direction with a transform component. and use the rotation, for example, and go minus 90 degrees. And that should sort of line them all up slightly differently, and I can do that. One way of moving this is like you can just enter a number as you might typically guess, but another way is use the mouse wheel and you get this cool menu. And this allows, as you slide down, different increments of increasing it. So if I want to increase it by integers of 1, I can just move it like that, slide left to right, and then slide up and increases it by tens, or increases it by hundreds, which it goes crazy, or really fine sort of detail, and sort of a nice way of increasing and decreasing thing. Also, if I do that on the value, see where it says rotate, if I right click there, this will increase all the columns there, which doesn't make any difference in this case, but might be useful later. So this tube here is currently set as a polygon, which I wanted, but if I wanted it as other things, I could set it differently. One of the challenges, and this is where it comes to the challenge of this plugin, is it doesn't actually let me send this kind of closed polygon as such. So I can basically, this is more to get the plugin working, which if the plugin was better, this wouldn't be necessary and it'd be a lot more file efficient. But for now, you basically use a divide component that's basically going to split everything into the separate sort of mesh faces as a list and copy them all. So if I look at the difference of the geometry spreadsheet now, and I go back to the points, that now I have 15,000 there, because now I have basically all of the primitive faces as a separate list that's there. So one kind of challenge here now is how do I get the colors that are like for the number of tubes and not for every single primitive face in there. And I might need to do a new attribute. So this kind of maybe touches a little bit on what Hesham's going to talk about in a second, but I do attribute create. And I put that basically before here. And I want to get out of the geometry spreadsheet and back to here. And I'm going to call this, I can call it anything I want, but I want to call it, let's say, point index. And the value of point index, I want it to increase or take basically the number of point, which is going to be $PT. And it gets this green because it's sort of linked there. So now when I go to geometry spreadsheet, I've got this point index here that's there. Not that it matters terribly much, but I could make it an integer because there's no actual need for it to be a floating value. So basically every point now has this point index matching the original number of scattered points. So that when I come to this thing, that all of these faces, this is now, I just click copy to points, all of these faces in this long list of faces contain the tube as a number of which they're part of. And that's what I'm doing there. So if I create a separate amount of colors, or I guess it's sort of, the colors are going to be there anyway, but if I do a file and I create a separate file here, and then back to here, and I think the reason I couldn't use the HIP folder yesterday is because I didn't have the file saved. And if the file's not saved, it doesn't have a HIP folder because the file's not saved. So, but I'm already kind of got the file name created, but I'm just going to call it that and save over whatever I had there previously. And here and save over here. Save over that file. And so now when I come back to Grasshopper, read my file again. So I get all my tubes back. And basically, there's different ways that we could send the colors through to read them here. So if I make a copy of this, but this time I want to read that second file that I created, which has just got _2 at the end. And let's see if that works. Yeah, I get a file there. So this is the file that's just been taken a little bit earlier than the other one. And I want Houdini attributes from it. And I need this attribute type. Oh, I need to put CD in here. So the point attributes are coming through, and the primitive attributes probably not, because I don't have this in the file at the right time. But get that out of there. There. Save that file again. Grasshopper. I reloaded this file, and maybe I did it in a different way. Well, I guess the number of points, I think it's fine, actually. So I have 3,000 colors there. And let me just check. If I join this mesh and then I do disjoint meshes. $661. Well, I guess is 29. I wonder, is this creating a different file? Let me just check. Yeah. This file was not overwritten recently. Let me just make sure this name is right. I think it's taking an old version of the file. Oh, I just realized the mistake. I apologize. I didn't change this from read to write, so it was just reading the old file. Okay, so that needs to write a new file. Now, if I look here, 1130, yeah, okay. So now that finally updated. All right, one little parameter and sent me all over the place. So now I can read this, and hopefully this file has now been updated. And that results in, yeah, there we go, 661 colors, right? So we have 661 meshes, 661 colors, and now I can do mesh colors, take my meshes. I'm just going to graph this before I connect it so that the data structures match. Control M, which will turn off the thing, and there I have my colors coming through. And then I can do a mesh join, so that's one mesh, so that I can just sort of display it at faster speeds because individual meshes will be slow. And to do that, I would flatten so that they join properly. And now within Grasshopper, now that that's working finally, let's say I go back to my initial tube. Let's display it here. And that may make the tubes longer and skinnier. And then let's scatter some more. But then let's change that back to 0. Maybe they're too long. I just turn off the normals here so I can see what's going on there. So let's say that's my final thing, and then I can save and then save. And now come back here. And with this, I could potentially just, let's say, delete this trigger from here and connect this one trigger to both of them so that clicking this trigger will basically reload both files at the same time. And it's sort of paused, waiting to sort of update. And that sort of brings us to kind of the end of the lecture from yesterday. Is there any questions on this, or is it sort of generally understood? Copy to points and getting tubes. Yeah, there we go. So now I have these kind of tubes loaded in like that. All right. I guess I'll pass over to Hesham to go into the slides and the attributes.
Yeah, amazing. Thanks, James. I just want to also emphasize that it's not only about bringing colors from Houdini to Grasshopper. So James is just illustrating the concepts here, but you might replicate the same workflow to bring anything from Houdini and to apply it in a different way as well. So you may use those attributes to, for instance, when we move to the third part tomorrow about tessellation, you may use those attributes to affect tessellation as well, right? So it could be used in any way, as you might use attractor points, for instance, in different ways inside Grasshopper. And this, to be honest, applies to everything that we are illustrating here. Could be managed or manipulated in different ways. So let me move to attributes, and after that we will have a lecture about noise, and then we can move to the second exercise. So let me do something. And so yeah, hands-on part in Houdini first. So again, I just want to take a moment here to understand for you to understand how you can manipulate attributes inside Houdini. So this is going to be like the very basics, but bear with me. And even before that, I will try to simplify my interface a little bit. So you'll see that, I think you're seeing my correct screen. Yeah. So for every single tab, there's this arrow where I can potentially close all of these extra windows. And here I will also close this one, this one, this one, this one, and only keep the scene view and the geometry spreadsheet. And even here, I'll just close everything, right? And I'll just leave this this canvas that where we can add nodes. So I will just start with a sphere. So sorry, geometry first. So to object, and then here we'll go to geometry. So this is just like a starting from scratch, make sure that you go to the object where you can actually add objects. I presume you know all of this from the introduction that you had already. And then I would search for that node, which is called geometry. And inside the geometry now, we can add anything that we want to add inside Houdini. So all I want to use here to illustrate different attributes is the sphere. So that's free to not add in as like a pinned window and just the same that only about geometries. For everything that you create, you actually add more attributes to this table, which kind of similar to how Grasshopper is operating. And if you move to vertices, you'll find this recipe for how the faces are connected. And then for primitives, you move to faces, and then for detail, you're actually moving to the whole object. But here, to start off, I would just change the connectivity of that sphere to triangles, or maybe even to where is that? Which sphere is that? Sphere primitive. So yeah, I'd actually go to the sphere No, it's fine. So with the same sphere, I would just change the primitive type from primitive to polygon, where we can get those tri-faces as a representation for that sphere. And then here, the way you increase the number of faces is that by increasing number of frequency. And you can do that by just sliding that slider, or by just using your meta scroll to actually increase the number of faces, or by typing a certain number here in the frequency. So feel free to tweak your parameters in any of these ways. And to create any new attribute in Houdini, and you will always need an attribute to be able to move faces and extrude faces or move particles later on. So attributes is kind of the key here to apply any transformations based on for vertices or for faces or for any kind of geometry inside Houdini. And to create an attribute, as James just did now, but it's going to be like a quick recap for those basic concepts, is that you go to create attribute, this node here, and basically what's going to happen that whatever you connect to that node, to read the input, to read the content of that of those geometries, and it will apply or it will create a new attribute for that particular input here. And when you select your attribute here, the first thing that you need to change is the name of the attribute, because this is the way that you can actually go back and call this attribute later on inside your Houdini process. So here you'll also find the name, and this kind of the key parameter in your attribute, so you can actually do stuff later. So for that particular one, I'll just call it weight, as in a weight for each of those primitives. And then if I just activate this now, go back to the geometry spreadsheet, you'll find that once you add this create attribute component, you will have this new weight column, which is a constant value now, and they're all equal to 0, which is quite expected because I haven't really changed anything here in my values, right? But again, this concept is very important, like how you can actually manage your attributes inside your Houdini environment. And it's interesting because now once we manage those values for the weights, we can use them to, let's say, extrude faces or move faces and so on. So if I change the value here to, and maybe let's maximize it a little bit. If I change the value here to anything, So just use my middle scroll to increase the values. If you go back to the geometry spreadsheet again, you'll find the new weights added to your spreadsheet. However, instead of using one constant value now, what I can do is to randomize those attributes. And we're gonna kick off our way to control attributes by random today, but we're gonna see different ways of controlling this randomness during the session. So I will search for attributes randomizer, yeah, or attribute randomize. And then this node here will take any attribute and it will randomize that attribute with like a certain domain. So here, if I go back to here, my attributes, so now the default attribute that this component is reading is something called CD. And CD is an abbreviation for color diffusion or color diffuse. So basically this is how they call colors inside Houdini. So you see here run an attribute randomize, the attribute name that is actually getting control on is the one named CD. And that's why once we create this, once we add this node, it doesn't really randomize weights by default. It adds random colors to each of the vertices that we have. So the way to fix this, hopefully you know already, is by changing the attribute name to the same one that you had before. So that's why it's really important to give meaningful names to your attributes, so you can later on reuse them in another way. So I go back to this, and instead of CD, I just call it weight. And now you see it started working, right? Because instead of those random colors that were assigned previously, now I only have this column weight, which is basically random values between 0 and 1, which is a good start now. At least we have those unique attributes for each of our primitives. And now we can actually use those attributes in different ways. So let's go back to the scene view. And the first thing that you might use to visualize different attributes that you have is the visualize attributes component. Have you used that one, James, yet?
Yeah.
Okay, perfect. So sorry, because I missed like one of the parts yesterday. So as you may know already, with the visualize node.
Sorry, did you mean have I used it in this tutorial? Like,
yeah.
Oh, then the answer is no. Yeah.
Okay.
I meant, did you?
No, of course you did in general. Like,
did I know what it was? But sorry.
I'm not testing your knowledge. Thanks, James. So the visualize node, the visualize attribute node, is the one that allows you to visualize attributes inside Houdini, which is a visual way to represent what's happening, right? And here the way you control this is that again you go in and again identify which attribute that you want to visualize. So to control this new node that we just added, you go to the visualizers here, right? I'm not sure why I always drew the arrow all the way from the node to, I could just do that. So here in the visualizers, you can just go there and choose which way that you want to visualize. Again, the name is all that you need here. So if I change that to weight, if you change that to weight, now you start to see different colors, right? Which are not meaningful. They're just representing random values now, but it's okay because we will like change this randomness later. This node is interesting because of different things, but we need to stop here for a second and recap like which geometry type those attributes were added to. Because when we created a sphere, it was identified as a polygon where we had like all of these primitive faces. And here, when we added the attribute at the first instance, we actually added it to the class point, right? So we actually changed the type. So and you can go back and instead of points, you can add those attributes to primitives, which means you should see them applied to faces now. So if you actually go to the geometry spreadsheet again, hopefully I'm not confusing you with like going back and forth from the scene to the geometry spreadsheet. If you switch from points to primitives, which aka as faces, so now you'll see your weights added to your faces, right, instead of your points. And if you go to the attribute randomizer, again, you need to change the attribute class from points to primitives. And now you see that instead of adding those colors to your vertices of your geometry, now you're adding them by face. So the takeaways from here is first to understand the difference between points and primitives. Let's just ignore vertices and detail for now. Just focus on points and primitives. Points are just points and primitives are just faces, right? And every time you add an attribute, you want to make sure that the class is right, whether it's vertices or primitives. And when you also randomize this attribute or control this attribute further, you want to make sure that you also set the attribute class to primitive as well. Even if you don't really remember all of this, as long as you're connecting your visualized node, you will understand whenever you're doing something wrong, right? Because you see when we changed this class from points to primitives, we instantly got the right feedback as colors, right? As a color for each of the faces. Any questions so far? Okay, so this whole introduction was just to make sure that we all understand the concepts of attributes. And like moving forward, if you want to, you can make the ranges as O2, which means instead of having min-max values, which should be from 0 to 1, right? Because that was our range initially when we created those random attributes. But you can also set that to O2 and get different colors. I believe you can also go in here and change your color scheme to any of these color palettes as well, which is nice. So now we learn how to visualize those attributes, right? Let's just understand how we can use these attributes in something else, which is quite similar to what you have just done with the spheres, for instance, or the tube that you created, but with colors. So one visual way here to check that is the poly extrude node. So the poly extrude node will take your will take a geometry and extrude it in a certain direction, very similar to extrude in Grasshopper. And if you connected your attribute randomize to this node now and enable this one, nothing changed, right? Because we still need to add a few things here. So we still need to make this component now to understand that those values are coming from the attribute that we created. And we also need to manipulate the values themselves. So here I can just play with those sliders. So by distance, we're actually, you see it's weird because now we are kind of scaling our geometry, but I was expecting to extrude faces instead of the whole geometry anyway. Do you know how we can fix this now in Houdini? Or at least like what do you expect to have there as a quick fix for this thing? You should expect that this is happening due to the geometry class, right? So maybe this component now is working on the whole geometry, the detail level of your geometry, not working on primitives or not working on your vertices, right? So we need to find something where we can actually apply this on individual elements. But here you see it's not by class, it's whether connected components or individual elements, which is quite similar to the previous logic as well. Because with Houdini, you have all of these different ways to access your geometry. And now since you're here, do I need to increase the scale of my text or anything, or do you see it fine?
I think it's okay. It's sort of small, but readable.
Oh, yeah. Let me quickly increase the resolution to 125, maybe. Yeah. I think it's going to be a lot of text today, so maybe it's better to increase this for now. Hopefully that's better. Let me get your face again because I can't see them anymore. Is that any better? Maybe it's not. I'm still here.
It's fairly similar. I don't know. Is it slightly bigger?
Anyways, it's fine. So thanks, James, for the feedback. So if we go back to the individual elements now, if we increase the distance, we're actually extruding all like every face individually. And if we change the inset value as well, now we are changing the inset value. By the way, now like every time I slide this, it's extremely like it's being increased with like a huge step. So maybe I can control that with my middle scroll and shift to another increment, and then I can maybe a little bit slower increase or decrease the inset value. So you see, once you hold your middle scroll, you can shift up to a bigger increment, or you can go down all the way to 0.01, and that will give you, or maybe 0.001, and that will give you a better control. But now we're still like extruding all of these faces with just like one fixed distance, right? Which is 0.155. But the end goal here is to extrude each face with the attributes that we created. So if you go, you'll notice that here there are 3 tabs: extrusion, spine control, and local control. So in local control, maybe it's hard to memorize all of these different controls, but hopefully by time you just familiarize yourself by how you can search for those attributes creators. So if you go to local control, you see that there's something called local attributes. And by the way, you don't even need to memorize those things. So if you go to search, for instance, poly extrude Houdini, you'll find the Houdini documentation, where you can search for any node that you're using and read the documentation about the inputs, the outputs, and how you can control the operation that's happening within that node. So always keep this documentation as your friend to go back, check references, and so on. However, it's not loading. It's coming. I'm not sure if my connection is a little bit slow today, but here you can see for this node, you read a few things about how it works and what are the inputs, and maybe a quick video of how you can do all these different types of stuff. So I dropped a link here, and you'll see that all the nodes actually that we can see in Houdini, they are on this left side, where you can filter or search for a particular node and so on. So don't even bother yourself with like memorizing all of these nodes for now. You can always go back to this documentation or ask Google if you need to. So yeah, going back to attributes, if you go to local control, now we can actually enable the distance scale. And instead of this attribute name that doesn't exist yet in Houdini, we can just add the same weight, which is, the same attribute, which is named weight, right? And now you can see that all of these faces are randomly being extruded using the weight attribute. You can also change the inset scale to the same attribute, which is weight. And now you can see that also the inset value of each of the face has changed based on the attribute that we created. And so on. So you can even twist the faces with the weight as well. And then like they will be slightly twisted and so on. So I will conclude this exercise here. The geometry wasn't the target, actually. The target here was to understand, again, the difference between points and primitives and how you can create attributes and start using the attributes, whether using colors or using another operation such as poly extrude. I'm not sure what's going to happen if I connected poly extrude with visualize. Yeah, it's keeping the same hierarchy of using the attributes to generate colors as well. But again, like one thing I like over Grasshopper at this way of handling all of your geometry as spreadsheet of positions and attributes as well. And I will make a pause now for a second in case there are any questions before we move to the second exercise.
Hi.
Hi, let me try to get your faces on again back. Yeah.
Okay, so I've got this basic question. I'm kind of embarrassed to ask, but I have this question that what's the whole difference between using Houdini and Grasshopper? I mean, for what kind of shapes we use Houdini, and for what kind of results Houdini is a better tool?
Well, you shouldn't be embarrassed at all. I think it's a very valid question. And I think Aster as well brought this up in the chat yesterday. I think you had this question whether this software is a niche software in architecture or not. Personally, I believe it's always good to add different tools in your arsenal of tools. So as a computation designer, it's always good to get your hands on all of these different tools because you never know when you actually get to use them. However, in Houdini, there is one specific use for that is much better than Grasshopper, which is like real-time simulations. Like when you get to simulate particle movements or any kind of these natural systems, it's way better to do it in Houdini over Grasshopper. And I'm not sure if you have tried that before in Grasshopper, but even with that little kangaroo script that we created yesterday, you might see that with more faces, it will take like minutes or even more than that to compute. So Houdini is very powerful when it comes to the simulation of particles and simulating natural geometry as well. I think in the market, the people that are using Houdini more are related to motion graphics and this kind of industry. But I haven't really seen many architects using Houdini. However, in the office, sometimes we actually use it especially if they want to, again, represent the movements of a certain behavior. Then Houdini is definitely the right tool to go to. So yeah, I think that it's the speed over all the other things.
On that project I showed earlier with the swarm patterns, the sort of maximum number of points that like Rhino and Grasshopper could really process was about 20,000 before the computer would crash, where Houdini could go up to 1 million pretty easily. And that's sort of a lot, and 20,000 wasn't really enough to really create that much complexity. So there's that advantage of using the GPU and the CPU to your advantage that Houdini does in a much better way than Rhino and Grasshopper, because everything in Rhino and Grasshopper goes back to NURBS, which is going to be sort of slower. So it's there's advantages there.
But we're completely sorry, Jane.
Just level of complexity can be way higher.
Yeah, but we're completely aware that you can't really use Houdini independently on its own, right? As an architect, because you might need to go back, add like very detailed geometries or move further to different stages of the project. That's why we are keen to also keep this connection between both platforms, right? So you can switch between the different mediums in a smooth way. So I'm not really recommending to just rely on Houdini for all of the computational work that you are applying. But yeah, just add it to your arsenal now, and hopefully you'll find a use for it
I
later.
also think of software tools like a kind of wood or metal workshop, where each software tool is like a tool, and if you just know one tool, that's like sort of, let's say you know sandpaper. Can you make furniture by chopping down a tree with sandpaper and then planing it with sandpaper and then shaping it with sandpaper? Probably it's just not a very good way to do it, and that's maybe the equivalent of Revit. It's a finishing tool, where if all you have is a saw, you can chop down a tree with a saw, but can you shape it? You need this sort of multiple tools in order to do different things. Like in a wood shop, you've just lots of tools, and it's about the wood shop bringing all these tools together so you can do different things at different stages of making furniture. And the same with software, that it's sort of, there's different design tools to sort of documentation tools, some for sort of high complexity might be different from low complexity, from NURBS to mesh. There's just different tools.
Yeah, well explained, James. We have said a lot, but I will add one last point here that well, I think it will make more sense eventually after today's session, because we'll show more powerful tools in Houdini and related to simulation in general. But yeah, I remember even like back in the day when I was when we were first like doing Grasshopper tutorials, people also back then were wondering how we can actually use Grasshopper on like daily basis, right? It's like, yeah, I just need to know Rhino and that's it. So I think with every new tool being brought to architecture, even people has the same kind of like wonder why we actually need this. And yeah, I think gradually we'll find like different usage for these different tools. So let's go back to the now. So let me share my screen. Hopefully that answered your question.
Yes, thank you.
Okay. So let's go back to Houdini. So now I'll just go back to our main node, which is the J1 node. And with that, you can just click on the object or just press U on the keyboard, and then you go one level up, right? And if you unclick this, you won't be able to see this geometry anymore. And you might give it a name as well, maybe attribute sphere or attributed sphere, right? So this was like the geometry number one, the exercise number one. For exercise number two, before we jump in Houdini, let's explain a little bit first about the theory of noise, because again, it's going to be the key part in today's lecture. So with geometry in nature, you'll usually find that there is a certain pattern of randomness being applied to the motion of anything in nature. And it's not really random. It's following a pattern, and sometimes it's more deeper than a pattern. Maybe it's trying to grow to maximize the exposure to the lighting, or it might be growing to reduce anything like as endangered to this maybe planet or this creature. And nature is very good at kind of evolving and growing in a very natural and random way. And you know, the first thing that comes to mind when we talk about the random growth in nature is actually using something like the random component or this randomized attribute node that we just used in Houdini. But the problem about using random nodes is that they generate numbers that have no relationship between each other. And they have no pattern. They have no predictable pattern that you can actually understand. So all you get is all of these random numbers that are meaningless. So today, to control this randomness, we're going to introduce Perlin noise inside Houdini. It's not the case that Houdini is the only software that has Perlin noise. It's being used in all different 3D modeling tools, and people are mainly depending on Perlin noise for computer graphics and simulations of natural behaviors. So Perlin noise is kind of like a gradient noise. It was invented by Kim Perlin, and as I mentioned, it's being heavily used for computer graphics and procedural art as well. And you may have seen this as a kind of very straightforward application to height maps and topography creation. It's not just like any noise. So on the left side, there's this image of the white noise, which is basically another representation of random values. But on the right side, there's this image for Perlin noise. And then you'll start to notice that there is kind of a pattern behind this random numbers. So you'll see that the dark areas are kind of following a certain logic versus the white areas, for instance, because here we're talking like about 2D representation of the Perlin noise. So before we start using Perlin noise, let's try to kind of decode what's happening and how we can actually generate Perlin noise generated numbers. So we are going to talk about the 1D representation first, And when you receive the lecture, you will see the reference as well that we're using, so you can go to those websites and check more about what's happening. So this 1D graph here is just representing random values, where you can just present them by this graph that randomly going up and down and creating this graph where you can then have values on the x-axis that are a representation for this kind of random movement, right? But the logic behind Perlin is that first you start by defining slopes. So on the x-axis, you start defining those slopes that are defining the angles between the different random values that you're going to generate. And with those slopes, as the first step, then you will actually move forward to the second step where you can actually start connecting those slopes with a different technique. And you see that on the y-axis, the values will go between, by default, will go between 0 and 1, and -1 and 1. And you will always expect to have negative values because this graph will go later up and down on this graph. So after you define the slopes, then the problem here is how you can actually get this sweet connection point between each of those two slopes. And by default, you will find that this very steep connections are being created naturally by just following these slopes. But people also invented like this interpolation method where you can start connecting those or having not the average between the different slope curves, but to interpolate between these values so you can have this kind of B-spline curves that are presenting the gaps between every single integer value that you are defining along this x-axis. So you have now this kind of sine curve that is being used between those different slopes that is responsible of generating your Perlin noise. And with just like one, you don't really get a Perlin noise effect, but with adding different interpolated sine curves using the same logic on top of each other, and when I say on top of each other, I mean literally adding this curve on top of the other one, and then repeating the process again, which is called octaves inside the Perlin noise. So octaves is like the number of the multiple curves or the number of the iterations that you are doing to actually achieve the Perlin noise that you are creating. So this process of after interpolation, keeping adding the interpolate curves on top of each other, you actually get this Perlin noise, which still, if you're looking about at this dotted graph, on the x-axis, you're still getting random values, but there is a pattern behind them. There is like a kind of a global logic that is controlling the random values, not just white noise as we saw on the first line. So that the previous slide was just the representation of Perlin noise in 1D. But in 2D, it's the same logic. It's exactly the same logic, but instead of starting from a graph that is being sketched along the x-axis, you are actually starting from a 2D grid of cells where each of the points is also where at each point of intersection, you're also starting to define those slope angles that then you are taking to also create the interpolation between those slope angles and eventually getting those random values that are representing a certain pattern based on the Perlin noise logic. It's a really interesting concept, and there are so many applications for Perlin noise. So it's not just for coloring, it's not just for texturing, it's not just for generating height maps. You can use it to do so many things. So you can actually use it as a way to control your random values or the controlled random values. You can simulate motions of a certain object, or you can even kind of simulate a natural motion inside your 3D modeling softwares as well. So there are so many applications. It's not really limited to one thing. Again, at the end of the day, you're just generating numbers, right? So, and the way that you feed in those numbers inside your model is totally up to you. So it's not really limited to anything. So yeah, let's go inside Houdini now and see how we can apply this concept. It's gonna be very basic, but it lies like a good ground before you move to the other part of today's lecture about graph systems. Hopefully, I'm not going to spend too much time here. So I'll again right-click, search for geometry, get the geometry. You may even rename it first to noise, and then go inside that node. Maybe I will decrease the size of that panel for now, and then let's create something. So for that, I'm going to create a plane, not inflate, just plane, please. Plane. Where is the plane? Plane. Really? Plane. That's off. So sorry, it's called grid. I'm being biased by my Grasshopper knowledge. So so a grid. So it's called a grid here. So with a grid, we are creating a plane that has a number of faces, and those faces are quad faces. And here, using this node, you can just increase the number of rows and columns. So let's just increase that to 200 by 200 for now, or maybe you can just use 400 by 400. So and you see, you can easily get this very high resolution representation of your plane easily in Houdini as well. And we're going to use this grid to represent the logic of using parallel noise inside Houdini. So just to illustrate, usually in the past, people relied on something called point wrangle inside Houdini. And with this node, you actually don't really use this node-based interface. You're mainly typing vex expression, like vex code, inside this node, which basically is something similar to Python, where you start defining the way you move points and the way you control your motion, but using the vex language, which is the vector expressions in Houdini. Luckily, we don't really have to touch on that. We have something called PointVop, which is vex as well, but it's a node-based logic, which means you don't really have to write anything as coding. You can just replace them by individual nodes. And the way you start playing with PointVops is that you connect your geometry here, and then we will dive inside this node for some time now. And to understand this node a little bit better, I would share a link here as a reference for all the parameters and the in and outs of the PointVop, because once you jump in, you will basically find two nodes, the in and out. So the things that you get as inputs from your geometry, which is the plane here, and the things that you get as an output from your process, right? So as inputs, you'll find all of these different inputs. The P is the position, V is the velocity, force, age, and life if you are dealing with particle systems. ID is the ID for each point. CD, the color diffusion. UV is vectors. Anyways, I'm not really familiar with like all the namings here because I haven't really used them all, but you will find in the document link that I share with you like more information about that. The N is the normals, time increment, and the frame number, the point number as well, which can be useful, and other attributes. And yeah, they are being color coded based on the type of each kind of category here. So I think the green means integers, and I think the green means float numbers, and the blue color means integer numbers. And yeah, you can actually, once you hover each of them, you'll notice I can't really highlight this now, but you'll notice that at the bottom part of my Houdini canvas, there is a kind of a more description for each one. So we are actually going to use only two inputs from here, the positions, right? The X, Y, Z coordinates of each of the points, and the N, which is the normals of each of the points or the faces. So those are the only two things that we are going to use in our exercise. And to start this, just to illustrate what's going to happen if you at least move like one of the points here, if you get displacement or displace along normal node here, right? If you insert your points and if you get the displaced points as your output here, and then in this place, nothing is happening because we have it to 0 now. But if we apply this, right, so if you apply this, go back one more step. Yeah, I should enable the, so you see if I go back one more step, I was only enabling the grid input, and by enabling, I mean enabling the display parameter here, the blue one. And without re-enabling enabling this node, you won't be able to see what's going on inside the point VOP. So just make sure that you tick this blue icon, and now you see that our plane has been moved in the Z direction. And that's not the intention for sure, but I'm just showing you how you can get something in the positions, displace that in the Y direction, it's not the Z here, and then you get the P out, and then that's it. You will get the output of your VOP node, VOP point node. But yeah, but what we're going to do now is we're going to find a component that can generate a per noise generated numbers inside Houdini. And it's called turbulent noise. So if you search for turbulent noise, you'll find this node here. So right click, search for turbulent noise, and then you'll get this component. And this is the one that you can use to generate purely noise driven values. And now we're going to use it to move our points. So before that, let me just delete this node. It's not important here. And to be able to control your geometries, I'll just use the positions now to my position here. So whatever you feed into the turbulent noise component, which will take it and generate random values based on that node. So if you click here, yeah, this inside VOP. And now the noise output can be just connected to the displacement node that we created as well. So if I get displacement, I can just connect the output here, and then I can just let's actually, before moving the points, let's just connect the noise here in CD to visualize the look of the turbulent noise, or the visuals of the turbulent noise inside Houdini. So as a reminder, CD means color diffusion, and this is basically the color for each vertices, the color of each vertex being displayed in Houdini. So before we move anything, let's just jump inside this node now, and let's understand more about how we can control how we can control all these parameters here. So if you remember from the lecture, we have talked about defining the slopes and defining the octaves between those slopes as well. So the most two important parameters here inside this per noise node is the frequency and the turbulence. So the turbulence is the number of octaves, which will define the number of different interpolated graphs that you can add on top of each other. And the frequency is how many number you're actually repeating, repeating the per noise, or how many slope angles that you're actually generating along the x-axis. Hopefully that is clear. But by default, you can also manipulate the noise type. So there's the per noise, there is the original per noise, what we're going to use today. But there's also other things like the simplex noise and alligator noise and other noise generators as well. So feel free to explore those different methods. But for now, I would just use the turbulent noise component to the original Perl noise. And visualizing the color is actually giving us this opportunity to be able to visualize what's happening. And let's play with those parameters. I will start by the turbulence. So I will bring this down to 0. And I can see that every time you increase the turbulence, you get, so the kind of the frequency of those dark areas is the same, but the more you increase the turbulence, the more you get those detailed representation of the colors as well, which kind of the same as adding, you know, more curves as you're adding more resolution to your Perl noise graph. So let me bring this to 1. And the frequency, if we manipulated that as well, you see that you're starting to control kind of the scale of your pattern, how many times this pattern is being repeated inside your linear environment as well. And maybe it's a good opportunity to switch the views to turn off the grid edges. So go there and make this as smooth shaded. Just to, so from here, all the way up here, you can just, I think I had something, yeah, I had some fancy features here that I can use. So if you go here, you can go and change this to smooth shaded. And yeah, so we can manipulate those parameters as we like, but let's move forward and use those values to actually move our points. Let me get the displacement, displace along normal. And for that, I need to move the points using, sorry, so I need to connect the points here in P. And the normals, you can actually, this one, which is actually controlling the normal vector, you can connect the n to the normal. And then the amount, you can just bring this guy here. So you are controlling the 3 different values. So again, the P is the position, so I can just connect my default points. The N is the normal, which you don't really have to connect. By default, it will move the points based on its normals, because Houdini is smart enough to convert those different data types. And finally, you need to use your noise to define the amount of the motion. And then the output of this process is the displaced positions, and then you can just connect this here. And maybe to keep the visualization, I will connect the noise to the CD as well, so we can get to see both of the motion in the Z direction and both the colors as well. So now you get this displacement in Z, and now we can go back to this one and change a few parameters. So I will increase the frequency like this, right? Maybe it's better to delete the colors, not sure. So yeah, let's increase the frequency for now. And let's play with a few things. So the amplitudes will basically control how much you're displacing your plane. Maybe like this. And then the turbulence is as well adding all of these different detailing or detailed graphs to your geometry like this. And now we are kind of more like creating mountains out of this plane, but we're going to learn how we can control this further to create like a different geometry. And the roughness will determine as well the connection between, or the relationship between, the frequency and the turbulence. So so if it's 0, no, we're not really allowed to use 0 here. But with the very low value, you'll see that you are actually losing more rough details to your per noise generated numbers. And the more you increase the slider, you'll get this kind of effect. And maybe like this. I'll leave this for now. I don't really need to use this one. But maybe I can increase or decrease the frequency. Anyway, we'll play with that later more. But let's stop for now and learn how we can control the generated numbers from the turbulent noise node. By the way, if you play with offset, it's basically time, which means you will get like the same displacement, but over time, which means you're offsetting the waves within a certain value. But for now, I can just keep it here. Doesn't really matter. I'll make a pause here in case there are any questions. Again, the goal is not just generate this water-like geometry. We will enhance the control a little bit more now. Any questions?
Yes, I have a question with the signature. Right now is in 1D. What's the difference between 3D and noise with this attribute?
Great question. We won't really touch on like the different dimensions of the noise, but for instance, if we go back to colors, right? This might be like a good representation of this, and I will just delete this wire. So here you see the vector, for instance, is a three-dimensional number, right? Because with vector you need x, y, z. The point is the same kind of. If you inserted your 1D noise into the color diffusion, you'll basically get just black and white because it's like 1D noise. But if you move to the 3D noise, you start getting colored because here you are using the RGB values, which is the three-dimensional. In our exercise now, it's I think it's fine to stick to the 1D noise generator, but yeah, it's kind of a different way to generate noise using the Perl noise algorithm here.
The next
Not
example.
sure if that was clear enough. James, yeah?
The example I'm going to show after we'll have 3D.
Okay, perfect. Let me change it to 1D now.
When you smoothed out the mountains, it reminded me of the J.G. Ballard book, you know, the Wind from Nowhere, where the wind has sped up after climate change to go really fast and all the world is like rounded.
I mean, when I changed the offset?
No, when you had the roughness as really smooth.
Okay.
And like a sort of, you know, future wind accelerated planet where all the mountains are rounded.
Yeah.
Sci-fi reference.
If you go all the way down to 0, then you get this kind of yeah, other geometry. So let's move now to control the turbulent noise even further. So there are two main components here that's going to be very useful. It's equivalent to remap node in Grasshopper and graph mapper inside Grasshopper as well, which is fit, range, and ramp. And you start notice that even though you're new to Houdini, but all of these very similar concepts will help you to digest the tool faster, right? And yeah, you'll find that once you're more experienced with one software, it's just as easy as this to, you know, to flip and jump between different tools. So hopefully you kind of get the logic behind these two nodes now. Fit will take your numbers and it will kind of fit the domain of the existing values and change it to something else. So if I connected my noise here, the generated numbers from the turbulent noise, which, as you remember, it should be varying between -1 and 1, as per the logic of the Perl noise. And here, what we can do is to say that the source minimum is between -1 and 1 as well. If left at 0, it might be a little bit confused about the values that's trying to remap, right? And then here you have the destination min and destination max. And this way you're actually controlling your numbers. So instead of having negative values, right? If I connected this now, you see that you're not really moving below the ground level anymore. So before, before and after, right? And so this is the fit function, which is a nice way to control values in general in Houdini. The ramp, however, is another interesting feature to control your the interpolation of your values in a better way. And it had this yellow color because this node is different. It's called a parameter node, which means we won't have access to this node inside VOP. We need to go out to be able to see what's happening. I'm going to explain myself now, but all you need to do is I really like this feature inside Houdini. I don't need to disconnect and connect again. I think someone made a plugin for that inside Grasshopper as well, maybe not. But yeah, so now you see I just connected the ramp between the fit and the treble noise. Sorry, the fit and the displacement. And I'll make a pause here in case you want to catch up as well. And nothing changed because we still need to, as I mentioned, like take one step back and manipulate the values of this ramp node outside of the VOP node. But this is more or less our setup. We're almost there. With tweaking the values, we should be okay. Here, I'll just switch between RGB color ramp to float ramp because we are going to change. And I think, by the way, before that, it wasn't like it should be 0 because again, we still need to adjust the values, but make sure that here you switch to the float values because again, the values that we're getting are float. And yeah, if you hover here, you see that you're getting float values, which makes sense because we have been generating values between -1 and 1, and after that between 0 and 1. Okay, so I'll jump back and get to the point VOP. And now you can see after adding this ramp node, we have all of these new features here that we're going to control now to change the interpolation. And by the end of the session, we'll learn how to expose all the parameters from the point VOP outside here so you can easily control and change everything just in one place. And if you go to here to attribute bindings, now you can actually change so many things. So let's leave the position to O2. We can actually leave everything to the default. We can leave it to ID. However, here, what we can do is to change the value because now it's 0, which means everything that's coming out of the map function is 0, right? And that's why, that's how we ended up with this flat plane. So if you change this value, means that now you're getting more, like you're getting back to the same setup, which means now you're having value between 0 and 8 or 0 and 7 and so on. So you can keep changing the maximum value here. And the nice thing here, the new feature, is this interpolation tab, which is really easy to manipulate. If I just click here on this maximize ramp, this node here, I'll be able to maximize this graph and manipulate the existing interpolation line. So I'll maximize this, and now you can see just like a linear representation. And if I just bring this down, means that I'm basically manipulating the values, and you can see the values down there is being changed. And you can easily add a new point by just adding a point here. And one more point. And one more point. So you see that you start to get cool effects by just changing this graph manipulation inside your kind of script. And you can change that. So now you're kind of creating those steps between your values. And you can actually switch between different types here. So if you go to settings, if you go here to settings, you'll get like default predefined graphs for you. So I might go for valley, for instance, or hill, and then you will actually start seeing your points moving in the Z direction, kind of following the, let's say, the desired interpolation using the per noise generated numbers. So the huge difference between just using random values and per noise is that you can really easily, by using per noise, to mimic natural behaviors, which what you'll be touching on way more with James in the second exercise. But at least with this one, we were able to kind of mimic this natural looking pattern just with a few nodes and per noise. And you can either play with this graph now to manipulate those, the way you get access to, the way you interpolate your values, or you can go inside again and play with the different attributes again inside your point vault. And you see that in the original file, I basically replicated turbulent noise again to add more details. However, let's keep it simply here. And I'll just show you how you can expose other parameters outside. Because every time you see, to be able to adjust the per noise node, you want to jump in, go to the turbulent noise, and this is the only node that you need to tweak, by the way. And you need to like change those values and go back to change the ramp. It's really easy. Just go to the settings, to that gear icon here next to your parameter, and you just click promote parameter, and then we'll get it outside. So click here, hit promote parameters for everything that you want to expose. So I will expose frequency, I will expose offset, I will expose roughness, and turbulence. So click promote, and you see, once you do that, you'll get those fancy symbols here that represents that you're actually exposing parameters outside of your WAP node, right? Hopefully you're okay and catching up. Again, we are kind of speeding up because we have so many things to cover. But if I go out now, you see I got all of these new parameters as well, which are gonna make it really easy to control everything from one place. And yeah, let's have some fun here. Also, you can go to steps, which then you'll get like this very sharp transitions between your points. And by the way, the initial setup for the grid was 400 points by 400 points. And if you click here, you see that you're already, if you're by your middle scroll, you clicked on the node, you see that you almost have like 500,000 vertices for that grid. I think if you lower down resolution, you might not get as good effect as we had before. So it's kind of interplay between your resolution and your setup as well. So that's why initially I increased that to 400 by 400 to just get like a fine resolution. But we can even increase that way more, and it should be still okay and manageable inside Houdini. So yeah, all I wanted to illustrate that you can create those different effects, but I'll go back to the hill now because it's the one that I'm looking for. And here, apart from, you can even add a point to kind of exaggerate a little bit and control the effect even more. And now, what I can do is to change the frequency if you want to. So now you can get access to all of these. What's happening? Okay, let's set them to 0 first. And then just watch out which level. It's called the ladder, I think, in Houdini. Which level you are actually increasing the value with, because with 1 or 10 or 100 might be too much to control. So here are manipulating the frequency, and this is the offset, which, as we said, it's kind of the time of the wave, which will represent more of the motion of your geometry. And the roughness is that there's all smaller waves, like the child wave that you will get based on your turbulence. And finally, the turbulence as well that can, if you change the roughness, you'll get those extra pumps here everywhere. And yeah, there are so many to play with, but I think I'm good to leave it here. One last thing, because by the way, one powerful feature about using Houdini is it's an animation tool, right? And this is like a completely different world inside Houdini, which means you can actually capture the animations of these motions, as I said, like all of these simulations very easily in Houdini. One example here about the offset, for instance, if I right click here on the offset parameter, you'll see that there is something called keyframes, right? And or the shortcut for that is Alt left click. So all the Alt left mouse button. But here you see that if I set keyframe here now with this current value, you'll notice that here inside Houdini, there's this green symbol now, which means they have set a keyframe inside your frame here, which is this one. And if you slide this up until, let's say, 240, which is the number of your frames, we can increase that if we want to. We'll learn about that tomorrow more. But for now, if I move the slider here to the frame number 240 and increase the offset to another value, let's say this, and again, right click, keyframe, commit change. Now, whenever you slide the slider, you will actually have the transition between the offset value. Keep an eye on the offset value, which was set to 1.2 up until 5.5. And if you hit play now, you will see your geometry in motion, right? It's a very simple example that shows just the offset being changed, but you can change all of these values together if you want to by setting the keyframes. Also, that goes without saying that now you learned how to bring geometries from Grasshopper, you can easily replace this node with anything else. So I will just stop the keyframe now, go back, and for instance, I can get the sphere. It won't be the same, like it's very obvious that you would need to manipulate the like your values, your attributes, your parameters to get the setup right. But here, if I replace that with a sphere now, go here and maybe change that by 400, and maybe I can copy this point VOP here just to keep the original one and connected this one, previewed on this. Yeah, you see that we have this kind of a balloon now. But if we go back, actually, let's keep the mesh faces edges in this case. Now I can go, I think I can keyframes, I can remove keyframes if I want to, but I will play with the frequency because this kind of a different geometry now. I may also play with the graph in terms of the maximum value, right? And then you see that you can really easily change between your original geometry and this one. You can also create steps, which kind of creating the planet Earth now. Yeah. So so with these setups, it's very flexible to switch between different inputs and even to input that's coming from Grasshopper, but I will leave that to you to explore on your own how you can integrate those techniques on geometries that you are bringing from different tools, such as Grasshopper. Stop sharing and check if there are any questions. Was that clear? I've been talking for an hour and a half now, so hopefully
Hisham, I have a question.
got something. Yeah.
Can we have a keyframe for to change the waves, curve waves, or the cubic wave? Can you share it?
The mapping function, you mean, or which one?
Yeah, share again.
This one?
Yeah. Can I
Ah,
change it through the keyframe?
well, you asked the hard question. Maybe there is a way. I think ah, I think it's usually associated with values, with like sliders or with numerical values. So for any of these, you can set keyframes. For the ramp node, I don't think so, but I would imagine that we can rebuild this mapping function because, yeah, I think I know something that could be useful. Because, those graphs are kind of mathematical operations. And like bias, for instance, is one of them. And if you go like bias or bias interpolation, yeah, not sure if I get a good reference here, but bias interpolation is one of these curves, right? And here, what's interesting about this that you can actually get access to the numerical values of those of this function, which you can promote, and then you can use keyframes with. I'm just saying that you can find a way to represent your graph as a numerical value, then you can use it with the keyframes, right?
Okay.
But maybe there is a smart way that we can use to as well to oh, we have access to the position here as well, right?
Yeah.
And we have access to the values of each of the points. So if you're patient enough, yeah, you can then set keyframes for each of the point and each of the for the points and the position as well. But there's another question of how you can. So you see for each of the points, you have different set of values. Okay, so it's doable. So it's gonna take some time, as you can see, but eventually, yes, you might get to somewhere.
Thanks.
But
No
one,
worries.
one other thing, like in Vex, you can start to code everything manually. So I mean, it's a good bit more complicated, but it's like you basically just start writing the code and write this value is this value is this, for loops and everything.
No, right on, James. By the way, the cool thing about point bops is if you right click here, if you go to Vex, you can actually view your Vex code, which then it's really easy. It's not as clear as it's actually not that hard, but it's a set of rules of you see, for instance, Prill noise here just being defined as the pi multiplied by the frequency, and all these equations you can get access to and write your own code that Jane just mentioned. And then maybe you can take this whole setup and expose it to a Vex node as a start, and then manipulate those values and then run your keyframes. But anyway, we're just learning the let's say the starting level of Houdini here. So let's not go to Vex now.
I also, if I could share my screen, I was just going to add one more
Yeah,
thing
sure.
on a break. So I just tested out, just back to that question about complexity and Houdini. I just made the thing really small, right? The tube. And now this is at 10,000 points. So if I add 1 0, that's 100,000, 2 zeros, that's 1,000,000, right? And now this will calculate. And within about 10 seconds or so, roughly, it
Good
should.
crash.
It worked earlier.
No, I'm kidding. No, I trust Houdini on
But
that
even on that previous
particular
example, when Hesham was animating that kind of thing there was sort of 500,000 parameters all moving at once, right? So now we're up to 1,000,000. So this is 1,000,000 scatter points and 1,000,000 cylinders, right? So if I go inside of copy to pointer attributes and I go into info, right? It's still a little slow, but I think there's like 182 million vertices or something like that sort of being manipulated. And to do that inside of Rhino, or 132 million vertices being calculated here. And to do that inside of Grasshopper or Rhino would be impossible. So that's one thing. And to do that sort of on an animation where things are moving and you could export this thing, also impossible. So it's just the level of complexity. And to add, I got book. One interesting book on the topic, Mario Carpa, kind of a more of an academic in London at University College London. This book's called The Second Digital Turn, and it sort of defines the first turn in digital architecture, the first, let's say, era one, as sort of a blobitecture, sort of smooth forms that maybe Grasshopper and parametric geometry was really good at. But where a lot of the experimentation is in the second digital turn, or what Mario Carper is classifying as the second digital turn, is away from these smooth digital forms in order to the kind of hair and furry and other forms of digital forms that you would need the kind of softwares like Houdini in order to kind of compute. So this sort of second digital architecture is quite experimental, but it's sort of no longer smooth and therefore requires these other softwares to do. And this idea of 132 million parameters is just not very Rhino or Grasshopper. So hope that brings some clarity to.
It did to me. Yeah, I mean, we all have some doubts, right, about the tools that we are using, right? So we don't really take one thing for granted. So yeah, we're always like looking behind the tools that we're using. So I think it's a good moment now to take a break. Let's take 10 minutes, or sorry, let's take 5 minutes because we still have some things to cover, and then we can go back in 5. Okay,
We come back at 5 minutes past the hour, whatever time zone you're in.
perfect.
Hi, everyone. I'm back. So turn on your cameras if you're back. I'm just going to go ahead and share my screen. So now we're going to look at growth in Houdini and bring that growth back into Grasshopper and then apply that to a surface we created in Grasshopper. But we'll start by creating the growth just on a general component. So I guess if you make a new file, and in this case, make sure you save the file because we can't use the HIP folder without the saved file, as I made the mistake yesterday. And when you have that saved, I've already saved my file, but guess we can start with a geometry node, as always. And you can always rename this whatever you want. So this, let me just call growth or whatever. Eventually, with more complex scripts, you're going to have multiple of these maybe geometries, and you can have the blue in this sort of parent view so that you can see multiple objects at the same time and then zoom into one and recreate it. So if I double click into growth, and I can start off with a circle. And immediately I see it's kind of not orientated right, and because I've got the Z up or Z up, so I'm going to put the circle onto the XY plane, and then it's backward, so I can turn off this reverse model, and now it's facing upward. So that's a different way than the reverse node that I actually used yesterday, like if I wanted an extra node, but in the case of circle, I can just do it with a checkbox right there. To get started, I'm just going to change some of these parameters. So my circle, this is the sort of number of edges, really. So the divisions, let's just make it 30 and change the radius to 2. And part of going through this example, kind of like Kangaroo, the way that it wasn't so much that the numbers mattered in terms of their dimensionality, whether it was 5mm or 500mm or 5 meter, but they do matter as relative numbers, as forces against each other, so that you have the same ratio of numbers as I'm using. And then when we kind of get this working with default values, you can go mess around with them later. So just make sure the radius is 2, 2, and the divisions is 30. And then we can use a triangulate node, which means we can control, which is kind of like try-remesh. So I need to click the blue tab to make sure it's open. And it's currently got a very low number of triangles there, but if I scroll down here, I can choose the refine button. So by choosing refine, then that gives me these options, which I can control the triangulation within the circle. So triangle sizes are currently unrestricted. If I'm going to set target edge length, and now this is getting very similar to try-remesh in Grasshopper, where I'm setting the sort of target edge length. So where is target edge length? Currently 100, knowing that it's currently a 2-meter radius, I'm going to make it 0.1. And now I can see that I get a much smaller target edge length. That minimum angle, I'm going to also just put as 2. And that's that component created. I also want to, I'm going to be using the normals later. So just from sort of general practice, put a normal component in here. And we can just leave the parameters as is. And then I'm going to create a new attribute. So that's attribute create, or to type it easier, a create. And the attribute we're going to use just the way capital C small d is color diffusion, that this one's going to be called p-scale. And this is sort of a point or particle as a scale, and we're going to use that as thing. I'm going to leave all of these parameters, I think, the same. And yeah, that's it for that side. And then I'm going to create a parallel branch here where I use an add component to add just add a point. And by default, it has 0. So I can click this plus mark. It's going to add a point. And the I can just change, let's say, the y value to 0.1. And then just leave that as is. And then I want to do attribute create for this one as well. But in this case, I'm going to give the p-scale a value. So let's make sure that's point, and then the value is 0.1. Okay. So then when we look at the geometry spreadsheet, you can see the p-scales there. Okay. So then we can create a solver component, which is where magic happens. And at the top, we've got these different inputs that when we double click inside of the solver, we're going to be using. So we can sort of make this one input 1, this one input 2. And when we jump inside, they will respond to that. So double click inside, and I can see input 1, input 2 coming in there. Also the previous frame. This default out thing I can just delete because I'm not going to use it in that way. It's quite often the case that you're doing that. And when this mesh comes in here, the first thing I want to do is remesh this mesh. Where am I going? Oh. I can connect remesh here. And looking at the remesh, the one thing I want to change is the target size here. And let's make that 0.01. So really small. And I guess I could do this. I'll just keep going for now, and I'll do a controller at the end. So now I can do point VOP, the same as we just used, which is the alternative to doing it in Vex. So it's sort of more visual. And this requires me to double click inside of it. And this is the menu we saw before. I guess I don't have to explain too much about in here, but right click, and we're going to do a different type of noise, which is unified noise as a component. And in that, we can make some Perlin noise. Get this, all these tabs that make this component like really, really long. And I don't need all these tabs. So they have these sort of kind of arrows here. If I click them, they just close all of them. And I need the other open. So I'm just going to leave it there, which just makes the component smaller and easier to deal with. And I want to take the original position, so P to POS. And when I have this click the unified noise, I can see up here at the top that I have the parameters. And this is where the signature can go from 3D input to 3D input, 3D noise. And noise type, I can make Perlin. And the frequency, I can change. I'm going to make this as 3 for all values. So I just did the ladder menu and moved that to 3. So all 3 values changed to 3. And then down the bottom, quite an important part, output range clamped needs to be selected. And then the new minimum for all of them should go to -1. And then we can just take the noise as a vector out of here. Or actually, sorry, it was actually, let me cancel that. I want to normalize the vector first. So for that, I can use normalize. And then n vector goes to n. So I'm getting those vectors out of there as n. And I think that's our setup inside of the point VOP. Yeah. So to get out of there, I can just use this menu here and go back to here. And then I'm going to do an attribute transfer and get a bunch of other values. And I guess maybe I'll just stop before I do that and talk about a slightly different thing. If I go back out to, let's say, out to this level, the growth level, and to the side, I'm going to make a null component. And a null component sort of sometimes is used for like just storing outputs and sort of renaming the output so that you can see it later. So I'm going to rename this output as controller in all caps. You can name it anything, but anyway, that's the controller. And here I'm going to go up to the settings kind of looking menu, the cog on the parameters of that, and I'm going to go edit parameter interface. It's opened on another screen. And from here, I can basically create a number of values all in the same place and link these values throughout the whole thing. So I can basically control all my sliders from one place. And I'm basically going to need float values and integer values. And basically, I just drag a float value to create a new float value. I just drag float to here. And I'm going to use 2 float values, let's say, and then an integer value, and then 2 more float values. And I haven't renamed anything yet. I'm just sort of putting them all in here as new parameters. And the first one I'm going to name, I'm going to call it point distance. And I'm just going to name the label the same. Some people do a difference of capitalization between the two, but I'm just going to keep it the same for simplicity. And down here is the range of the value. This is sort of the max and the min of each slider. So I need to sort of put the checkbox beside range, and let's make this between 0 and 0.5. You press enter to make sure it commits. And then the next one, I'm going to do name, and I'm going to do circle radius. And circle radius again. And then I'll do range, and this one I'll do between 0 and 5. And I use that to control the overall size of our circle. And then my float value, I want to call noise frequency. And for the range there, I'll just keep it at 0 to 10. And that's going to be the float value, so it's sort of got decimal points. And then the next one is just going to be distance and then radius. So distance. And this range is going to be 0 to 1. And the next one's going to be radius. Also range 0 to 1. So just to kind of go through it again, point distance is a range of 0 to 0.5. Circle radius is second, and that's a range between 0 to 5. Noise frequency is a range of 0 to 10. Distance is a range of 0 to 1. And radius is 0 to 10. So let's say take circle radius first. So let's go apply and accept. And now we get these sliders here. And let's say for my values, I'll just make this one 0.1 to start. This is going to be 2. Let's say the noise frequency is 3. And then we can go with 0.2 and 0.4. Okay. So now all these sliders are just here inside of this controller, and I can kind of just click back here and get them all. So to get these to work elsewhere, right click and I go copy parameter. And once I copy the parameter, it's Control V will not work for this because I'm not pasting the value when I get back up to circle here. So for the radius, I have to right click, make sure to just delete the value, because if the value is stuck in the link there, it can disrupt the link. So paste relative references. And I can do that here as well. But delete the 2 and paste relative references. So now if I go into my controller and I move circle radius, that will move my thing there. So yeah, and then if I take noise frequency and I copy that parameter and I go inside my solver and inside my point VOP and into my noise, and where I did this frequency and I did the 3s, just delete the 3s and paste the relative reference into all of them. So now we can control this value from the controller and we don't have to come all the way back into this menu. So now I'm going to do back to the attribute transfer. So I can just do a transfer, which will get to it faster. And I'm going to go away from the attributes and go to conditions. And here, I'm going to change the kernel radius to 0.1. And the max sample is going to be 4. And then this is where distance and width. I'm going to use 2 things from the controller to control these because I want them. I might want to kind of move these later. So I can go back one, oops, back here to the controller and copy the parameter for distance, and then back into the solver to attribute transfer and the distance, delete them, and then paste relative reference. Now, if I look at the reference here, these 2 dots mean go back 1 level. So this is sort of go back a level, back to the controller and take the number distance. I can, given that the radius is in the same place and I know what it's called, I can just copy paste the text here and put it as radius. And that should, as long as this goes green, yeah, that should be working fine. And to check that those numbers are coming through, I can just left click once on each of these and see that they're currently 0.4, 0.2 as they are, and they're still green background, which means they're sort of linked to the controller. So I can leave these as 2 links there. And that should be fine for there. And lastly, or well, 1 or 2 more components to get this working, do point relax and I think max iterations, let's make that 1. And point radius scale can be 1.2. Okay, let's just see if we get motion working here. Okay, so we have some issue here. Yeah, okay. Well, my notes too much. Now if I drag this over here, the attribute transfer, I'm going to transfer, I need to connect it to input 2, which is that sort of point line that I created earlier. And because I left it on, it's going a bit slow, but there we go. So visually, I've got my normals on here, and I want to turn those off. And now if I just see what this looks like currently, I can press play here. And why going so slow? Did I change? Let me just. Let me just go back and check the controller. Let's put a smooth component at the end, which kind of completes this section, and strength to 15, and I must have done something wrong if this is going so slow, but I lost control, take control. Something must be wrong. One thing as well, just when we're on it, this little button here on the bottom left, that gives me the menu to control the start and the end of the frame. I might just put that to 100 currently, and I can put it back to something larger later. Okay, let me just check my notes to make sure I didn't go too small with some value. This seems like all right. Hesham, you don't have any idea why this is going so slow, do you?
What, Jane? Are you asking me?
Yeah,
Um,
I know you haven't.
no, I'm not sure. It's hard to tell without.
Um, idea. Mm. I'm gonna move and open the one I made previously and just check through what I must have done wrong.
Maybe it's related to the promoted parameters. If it's worth it, maybe if you prefer, maybe you can bring the pre-made version and like go through the steps. Um,
Let me
it's up to you. Your call. Yeah.
I'm gonna like open another version. This is quite intricate in terms of all the settings to get this working properly.
Yeah. I think it's a better approach in general, like because sometimes I also get excited about promoting my parameters first, but then I find maybe usually it's better to make sure it's working, then you promote your different controllers. Because with Houdini, yeah, like you forget one thing, one class or one yeah, one parameter, and then you actually have to go all the way back. But it's fine even if we go through the steps of the pre-made one, and then I think it's better now for them to understand the logic, and they can definitely take their own time to practice later.
Yeah. It's going a bit slow. So did I skip? All right, I won't bother comparing it. I'll just so this is what should have happened at this point. With all those parameters linked in, and oh, I think in this one, which is an alternative option, I instead of making a null component and adding the sliders there, I just used the solver and did the same edit parameter interface and added them all here. But other than that, it's probably the same. So I'll double check afterwards and see what I did wrong. Which I guess you can see how intricate this is. I can't think of anything. Yeah, I'm just not sure what and then I guess just get the normals again and smooth again. Maybe I might just copy this in and just continue from there. The file's not there yet. List, yeah. So let me go to the other one. Okay. So now I can, yeah, kind of as was below there, just get the normals again from the new mesh and then smooth them one more time. And then control the strength here. So I can do, say 30. And now this will sort of iron it out more than it was previously. And then we can, let's say the next thing, we can sort of just put this on any frame that we want and make a file component to export it. And then if it's saved, it'll be the hip folder. So I'd go to my JSON folder and this is yeah, here. So I'm just going to call it growth out. And this is going to write the file when I connect this. There. So now basically this is being exported as a mesh. And then going into Grasshopper using a similar process that we've already done, that I can read the mesh, get a file path to create a folder. Select a directory. And I want it to be the Houdini JSON folder, wherever the JSON files are. So this is JSON folder and concatenate. That with the name of our file, which you need JSON, which I call this. And always double check when copying in to make sure you don't have any enters, like new lines at the end there, because that will destroy this. And I can see, make sure the file path is right. Wanted there, and just read this geometry with a Boolean. And there it is there. So now Houdini primitives to sort of open it up. And there it is coming through. And as before, this comes through as all these like separate meshes. So I can do mesh join. And if I wanted here, I could sort of do smoothing within Grasshopper if I wanted, you know, under the control here. So I can choose a level of a Catmull Clark to be 2 or 3. And those off. Just Control M to get rid of the mesh edges. And there I have that there. And if I open up Houdini again, that's my leverage. So if I open up Houdini here, and I change the frame to a different frame, do a deeper thing, and then I can just click this to make sure it's sort of saved the new version, and then go into Grasshopper and put a trigger and lock the trigger and put that towards the read and then update it. That therefore I get the updated geometry there. So that's kind of how we do growth. And below here, I'm going to create a new surface and then just quickly change the surface that I start with, rather than starting with a circle in Houdini, to start with something that we made in Grasshopper. So this kind of requires the Lunchbox plugin that I forgot to mention, but you can do a paraboloid here. Turn the previous version off. And with the paraboloid, I'm just going to set, make it quite small. So I can just do some sliders and do 2 for the first one for A, 2 for B, and 0.25 for S, which is the scale. And that gives me a paraboloid that can be manipulated quite easily. And then same as kind of in the previous time, that we have different ways that we could mesh this. I'm going to use mesh surface because I'm meshing a surface, which gives me a really neat mesh. I'm going to do Control M to put on the, so I can see these lines again. And for U and V, let's do 25 for U and 17 so for V. And then just to move this up above in the Z direction, I can just do move and unit Z. And with the dimensions currently as is, that will sort of perfectly rest on the ground plane. Otherwise, I'd need to calculate it in a more complex way. But if I move this one, it will stay on the ground plane. If I move this one, it will change. So, but yeah, so it's sort of on the ground plane. And I'm basically going to bring this this surface back to Houdini, and then kind of a little bit similar to in Houdini, the way I created, where is it? This point here. I want to create this slightly different in Grasshopper. So from this moved surface, I'm going to do populate geometry, because I could evaluate a thing, and I'm just looking for one point on this. And then I can use a seed value to control just selecting one point anywhere on that surface. You can kind of see the green point over here, move wherever. And then I can do a vertical line from this. So I can use line SDL and just make SDL 0.1, which is the same value as I used in Houdini. And you can kind of see that one line there that's sort of directing the growth. And now I just basically want to create two write files. So create two of them, one for this line. I might just convert it to a curve. Kind of see that loads there as line 10 millimeter, or this change it to a line like curve. And that's going to be my primitive that I write. And this is the surface. It's going to be my surface that I write. Then I can just copy this here. And I'm going to overwrite it on these two names here that I guess for me already exists, but you can call it whatever, but I just have it as SO2 underscore paraboloid underscore in. And I've kind of just used in and out at the end as relative to Houdini. That's sort of a JSON that's coming out of Houdini, and this is a JSON that's going into Houdini, so that I know from my file naming how each of these is being used. So this is going to be the name of my file. And I can just copy that and add points at the end, underscore points. And if you were to spell this slightly differently, or just those files didn't exist, it would just create them, I think. So that's going to file path, and then I make a trigger. And I can use the same trigger for both of them because I'm going to save them at the same time. So I'm going to connect the trigger to both thing and lock it. And then I just need the right value to be true. So Boolean toggle true. And I guess I can just use the same one for both. Okay, the second one. So if I press play there, which I just clicked, that will overwrite those two files to whatever this is. So now when I come back into my Houdini, also like when you save a Houdini file, if you save it and you have this blue tab on file active, that means when you open that Houdini file, it will automatically save the JSON or resave the JSON. So you probably don't want to save Houdini files with these kind of file nodes active, because then you're sort of just automating an overwrite by opening a file. And at the top here, I'm going to bring in, using the file node, bring in two files. And one of them is going to be my points file, and one of them is going to be my primitive file. So paraboloid in is the first one, and paraboloid points in is the second one. And there's that coming in there. And I'm basically just replacing the circle triangulate the normal with the paraboloid. So now instead of this triangulated circle, it's starting from this paraboloid. And same with the points that it's going to go into this add there. And now hopefully this works. That so it won't restart till it gets back to 0. I can just move it back to 0 and then see, did this work? And there we have sort of growth on a surface that we created from Grasshopper. Are there any questions just even about how this works? I know it's probably going to have to do it afterward, but. All right. As one, I guess just some last steps. What should I do? When we get down here at the bottom, one node that I just wanted to it's just one node there, is extract all points versus scatter right? And this is where all the points in the model, without changing anything, are going to be converted to points. And if I did copy sphere to points, that would give me all of those points, where scatter is taking that that mesh surface and just scattering any number of points we want on it. So we have this force total count variable here where we don't have it on this one because this is just all the points in the model. And we could use the example, I won't go through it now, but the same thing as we did in the first exercise that I sort of finished today, where I do copy to points and copy a tube and take the normals or copy a sphere. And you could sort of continue that workflow exactly there. As just one last thing I just want to cover before we finish today, is just putting a material on this. And we could put a material on after we did copy points. But it's very fast, just a basic material. So for that, we need a material node. And currently, if we look in material, we don't have any materials there. So we're currently in the object network here. And if we kind of get out up to the top and then left click here, we see what these other networks are that we haven't really looked at yet. So in MAT, which is material, if I click in material, there's sort of nothing in here currently. And if I just tab and do classic shader as the extra A, classic shader with the two cherries as the most basic version of a material shader. And I can just change the color, which is popped up outside, to red or whatever color. And that's now red. At the top, the name here is classic shader. I can just put a color red. And then top here, I have all these other options about my material that I could go through, like make metallic reflection or roughness or whatever, right? Yeah, but you can just make different settings to the material there. And then we can go back to object, into growth. And if I take this, this mesh and I put this to the material, so I'm not going the points route and to put the material onto the spheres that go onto this, but you could do that as well. So if I just use this material, and I haven't set a material yet, right? So in material, this sort of one here, that I can click this end menu that just says what materials are available, and I use the plus button, and I say color red, which is the name of the material I just did, and I can see that kind of goes red like that. And now when I go out to my main view, let's say I get this sort of full sort of shiny red there. And just as one extra shortcut, this grid is on here. If I press, or wireframe as it would be called, if I do Shift W, that gets rid of the wireframe and the thing. And now if I press play, I see the kind of growth on the red. And that's sort of the end, I guess, of this growth session.
Amazing. Thanks a lot, James. I think that a key point here, like with different exercises, we try to introduce you to Bob logic inside Houdini and how you can control the motion of your vertices, whether with the noise example or even this one, which is also dependent on the noise logic, but here it's kind of more evolving, right? And I think that the most obvious exercise now for you is to start bringing geometries from your crossover environments in Houdini and then apply any of the logics that you have learned today, and then post your amazing stuff again on Mirrorboard. We'll be posting, like I have uploaded part 1 twice, the lecture as well. We will do the same for part 2. And then, yeah, hopefully we'll just take it from there. Tomorrow we're gonna expand a little bit more about animations in Houdini And then we'll talk about distillation in Rhino and Grasshopper. So bringing those geometries back from Houdini, how we can process the mesh and apply different distillation techniques. Hopefully you have learned something today. I know it might seem a little bit overwhelming with all of these new concepts, especially in a new software. But give it some time, and you have the recording, so visit those videos from now to then when you have some time, and then you will get it right. Are there any general questions before we leave today?
Is anyone enjoying the workshop? There you go.
Crush. Hopefully they won't crush. They go until they reach the limit of your keyframes. So by default, you see that you have 240. I'm responding to one of the questions in Zoom. So the measure is asking, do these keep growing to infinitely or till they crush? So they just keep going until you finish the number of frames you have by default, which is 240 frames. You can increase the maximum amount of frames, and then they will just
I
keep
changed
going.
to 100 just to shorten it, but in that bottom left corner, you could increase it to way beyond.
You can just double click and change the number, and yeah.
Sometimes, depending on what you're running, sometimes the amount of computation, let's say as you grow, is the same amount, so you could keep going forever. But if the amount of computation is exponential based on what you're doing, well then as you get from, let's say, 240 to 480, it's going to be a lot heavier than it was from 0 to 240. And as it goes further, it's going to get even heavier. So for example, like if on every frame you added 1,000 points to the model, so you went from 1,000, 2,000, and it just kept adding points to the model, there would be a certain amount of frames that you get to, and it would just start slowing down a lot. So
Yeah, exactly. So yeah, expect another assignment today. We are looking forward for your amazing work again on the mirror board. We'll create a new column. We'll send the details on the email afterwards. And yeah, see you tomorrow. Thanks for joining.
I'll add those working files immediately to the drive, so they'll be there in like 5 minutes. And I'll investigate what went wrong.
Yeah, if we have any further clarification on that part, maybe we can share like another mini video or something explaining anything that was missing. So anyways, stay tuned, and then we'll share any extra information on email afterwards. Thanks all. Bye.
Thanks. Bye.